get like wherever it is you normally take notes, I'm gonna hit the record button. I already hit the record button. Great. I'm gonna record this, and that way when we end the meeting, if people miss the class, I can post it for them later. It's not gonna record you, it's only gonna record the screen. So that's good. Okay, everyone. So we are getting ready for the Unit 6 test either tomorrow or Friday, depending on what period of class you are in. For the test, here's some things you can do to study. Right? Studying for a physics test is kind of like practicing for a baseball game. You want to practice hitting the ball and doing the swing. You want to practice that so many times that when the ball's being thrown at you, you know what to do. You don't need to think to yourself, oh, right hand over left, then swing. Right? That's why I think the best way to study for physics is to do practice problems. Homework 6.1 and 6.2 are practice problems on field, charging, force, potential, and energy. Homework 6.3 is optional. Your class would have done it this week if we didn't have a snow day, but we did drop some of the material. Homework 6.3 is posted in Drive. If you would like, try problems number 1 and 2. Those include material that are going to be on your test, but feel free to skip problem 3 because we dropped that material. Okay, other ways to practice. Your class would have played quizzes yesterday on field and potential. So on the homepage of Classroom in the stream, you're going to see 2 links for quizzes. One is the quizzes from last week. One is the quizzes you would have played yesterday. That's good because it's got multiple choice that meet the standards for this unit. And the last thing you can do for practice problems is work on the Unit 6 review, informative. That's probably closest to an accurate assessment of how well you're going to do because it's informative, our test is informative, right? It's got all the standards, your test has all the standards. Aha. And for all of these, you can check your answers. All the practice that we provide has answers associated with it. Homework 6.1 and 6.2 and 6.3, those answer keys are going to be up in Drive. Even 6.3, where it was an optional assignment. For the Unit 6 review, there's a video associated with it. In Classroom, if you go to the Unit 6 review, you'll see there's a video associated with that assignment. So once you're done and you've tried out the problems in the review, you can go back and watch the sections of the video you struggled in. And then quizzes, its answers are built in, so you don't get a separate resource for that. Last thing you should do for yourself is make sure you have some sort of note sheet or equation sheet. And double check to see that you have the right things written on it. I've seen people do whole sets of problems wrong on a test because they wrote the wrong equation on their equation sheet. If you want a guide for what equations there are, on the back page of Homework 6.2, it has a list of all the equations, vocab, and the powers of 10 in metric. All of that is on the back page of 6.2. Okay, so from here, now what's going to actually be on your test? If you've been to our classroom, you know that I have this unit map on the back of the board where I teach. And the unit map has all the main ideas in one concise place. The big idea for this unit is that electric charges distort the space around them. That distortion causes a field which creates forces. You can also think of that distortion as creating potentials, where positive potentials are near positive charges and negative potentials are near negative charges. And potentials create potential energy. So fields go with forces, potential goes with potential energy. All right, so let's talk content for a sec. You need to know the parts of an atom. You need to know that an atom is held together by electric forces. So the electron orbits the proton because it's a negative charge orbiting a positive. You need to know how to use that elementary charge to calculate net force. So be able to use this 1.602 times 10 to the negative 19. Like if you had 15 extra electrons, how much total charge is that? Right? Or if you have 5 coulombs of charge, how many electrons are there? Be able to use this 1.602 times 10 to the negative 19th to find charge. In general, be able to describe what it means to be positively or negatively charged. Positively charged means you have more protons than electrons. Negatively charged means you have more electrons than protons. And that's why generally the electric force cancels out for macroscopic objects. Because me and my coffee mug and my car all are approximately neutral. We all have about the same number of protons as electrons in ourselves. So for the most part, we're going to end up being electrically neutral for macroscopic objects. The mathematical standard that you need to be able to do in this slide is be able to calculate net charge. That's like on the front page of homework 6.1. Also from homework 6.1, be able to calculate electric force. That's a different mathematical standard. So if you knew that charge on these two objects and how far apart they were, you should be able to calculate net force, be able to use Coulomb's law, either be able to solve explicitly, so solve for number of newtons, or solve proportionally. If I double the force, how does that, if I double the charge, how does that change the force? Or if I double the radius, how does that change the force? Proportionally might mean that doubling the radius gives 1/4 of the force because it'd be over r squared. So 1/2 squared is 1/4. But now, one of the big things on this unit is there's lots of vocab. So there's not a lot of math, there is a lot of vocab. So I put in one picture of charging. There's actually 3 methods of charging. This picture shows induction, but you should be able to do conduction and friction as well. I can tell this is induction because I have an object that's brought close, so the balloon is brought close, while the sphere is grounded. I know it's not friction because the balloon is not rubbing on the sphere. I know it's not conduction because the balloon is not touching the sphere. This must be induction. So we should be able to tell apart the 3 types of charging. We should also be able to tell apart insulators and conductors. I know, for instance, that this sphere is a conductor because the electrons were able to dissociate completely away from their resulting atoms. These electrons were able to literally move all the way across that metal and out to the ground. This leaves the sphere as polarized. It's polarized because one side has a charge. This side has a charge of +3. The other has a side of -3. So even though if we disregard the ground, the sphere is net neutral, it is polarized. Polarized for conductors looks like the electrons literally move to one side or the other, completely dissociating from the atom they were originally with. However, let's say we draw an insulator on the side here. Let's say I bring a negatively charged balloon by. There's the balloon with its negative charge. An insulator can't let its electrons go wherever. So what it does instead is the atom of an insulator will rotate. The electron cloud will move as far as it can without dissociating from the atom. I can tell this is an insulator because the little circle around the picture of an atom is showing that my atom is staying intact. The electron cloud is moving away from the negative balloon, but it's still an atom. It hasn't left and become an ion. So in this case, let's say this is a neutral but polarized wall. I can see the wall is clearly an insulator because the electrons didn't leave the atom. They didn't go over here. This proton and this electron have completely dissociated from each other, so I know that must be a conductor. Now, how a polarized object reacts near a charged object is it always attracts. It always attracts because the electrons always move to where they need to move to cause attraction. If you look at the picture here then, the sphere has a positive charge on the left. So the sphere is attracted to the balloon. The negative charge does cause repelling, but it's smaller because it's farther away. So a polarized object always causes attraction because it's closer to the charged object. Last one on the bottom here. The ground can be used to neutralize the system because the ground has an infinite supply of electrons. In this case, the ground can hold as many electrons as are going to flow out of this sphere. So if I take out my forces, maybe 3 electrons flow out. I'm picking 3 so that the right side of the sphere becomes neutralized. If 3 electrons leave the system, this means that the right side becomes neutral and the overall sphere is positive. That's charged by induction. It's induction because they don't touch, they don't rub. You just brought an object close and gave the path for an electron to escape. Great. Which brings us to the stuff we did last week. Last week, we did fields and potentials. And we like these fields and potential maps. For drawing, you should be able to draw the field of any 2 objects. So let's say it's 2 positive or 2 negative or a dipole. Be able to draw the field of 2 charged particles or 2 charged parallel plates. But more importantly, if I give you a field map, be able to do these 4 things. So if I give you a field map, be able to tell where the electric field is strong versus weak. Between these 2 orange points, I see the electric field is strong where it's closest to the charge, because that's where the field lines are closest together. If I didn't know what charge this was, I could figure it out because I see that the field lines are pointing away from it. So I know that this blue charge must be positive because the field lines point away from positive charges. I also know the blue charge has a larger magnitude than the other one because it has more field lines. More field lines means more charge. Last one then, identify the direction of electric force on a charge placed in a field. If I had a positive particle and I put it right here, my positive particle would repel away from positive. Its force would be away, and it would travel along this field line, roughly along this line. But a negative charge placed in this field would have a force that attracts along the field line. Because negative is attracted to positive, a negative charge goes against the field line. It's still going to take this nice curved path that the field line lays out for it, but it goes against the direction of the field because negative is attracted to positive. Similarly for potentials. For potentials, you're mostly going to have to be able to identify things. In fact, for potentials, you don't have to draw your own at all, but you should be able to look at potential versus potential energy. So be able to read the potential off point A and point B, right? Be able to use that potential to calculate potential difference. So let's say I take point A and point B. If point A's potential is 25 and point B's potential is 35, I see that my change in potential is positive 10. As a particle is brought from A to B, it gains a potential of 10. That 10 volts creates positive potential energy. For electric potential energy, that's the whole like PEEL is equal to Q delta B. Where I'd put in Q is the charge and delta B is 10. It's how much the potential has changed between 2 points. So to give you a mathematical example, what if I said this was a proton? A proton has a charge of 1.602 times 10 to the negative 19th coulombs. And if I brought it from A to B, it has 10 volts of potential difference. This potential energy is 1.602 times 10 to the negative 18th joules. When it's at B, it has potential energy. That potential energy could then change to kinetic energy so that you could find the speed. Good practice for this is going to be at the end of homework 6.2 or problems 1 and 2 in homework 6.3. A last kind of weird one on here is be able to tell what the unit of volt means. So if I said something has a potential difference of 10 volts, what that 10 volts means is that every coulomb of charge that you bring from A to B gains 10 joules of energy. Volts is proportional to energy. So since volts is related to energy, I would expect it to be related to the unit of joules. And once you know how much energy there is, that energy can change from potential to kinetic. All right, now what we would have done this week is we would have looked at the energy stored in a capacitor system, a system where you have a positive charge on one side, a negative charge on the other. But the only thing we're going to keep from this section that we're going to keep on the test that you'll be responsible for is the electric field in a capacitor. Inside a capacitor, the electric field points from positive to negative. So in this case, the electric field points straight down. And we get these nice evenly spaced field lines. What that means is any points inside a capacitor, all points inside capacitor, have the same electric field as each other. So points A and B have equal electric field. Because think of their field lines. A and B's field lines have the same density. They're not closer together at A or farther apart at B. Since they're the same distance apart, they have the same field magnitude. What they have that's different than each other is they have different potentials. A has a negative potential because point A is near a negative charge. So they have the same electric field, but A has a negative potential because it's near a negative charge, and B has a positive potential because it's near a positive charge. On homework 6.3, if you want to practice this in particular, problems 1 and 2 will do it for you. You can skip problem 3 because that has to do with the energy storage, which we're just not going to do. But with that being said, that is all the stuff that's going to be on your test tomorrow. Right? So in the meantime, make sure you've turned in all your homework if you haven't done so already. Homework 6.3 is in Drive and it is optional. I suggest try problems 1 and 2. We've got 2 quizzes from this unit that you can go work on, whose answers are built in. And you can go play on GoFormative and take like a practice test. All right, guys, so I'm gonna stop record. Good luck tomorrow.